So welcome everyone. As was said in the intro, I do a bit of illustrating, which will come in. I didn't do this one, but I did this one. So we already introduced all of these fun facts. Oh, thanks. Someone mentioned that my space behind me was cute, and I appreciate that very much. As was said in the intro, I also care a great deal about making technology accessible and making learning materials accessible in many forms. And earlier today, I had my first live stream on Twitch, and it was a bit of a mess. So I've had a few technical difficulties today, but we actually got it done. What I was doing there, by the way, was running a personal blog on Kubernetes, and we did get it running on Kubernetes, though we didn't get it hooked up and online. But we'll have to do that next time. Anyway, that was a fun fact. Yeah, so you'll see a few more of my illustrations and a few more of the ones that are not mine as well in this presentation. So today I'm going to teach people about open source Kubernetes and also about Kubernetes in the cloud with Google Kubernetes Engine, which I probably should have spelled out on the agenda slide. But Google Kubernetes Engine is Google Cloud's managed Kubernetes service. So that'll be in the cloud environment. But first, we're going to talk about open source Kubernetes. So starting with open source Kubernetes, it's good to start at the very beginning, as they say. And for Google, the very beginning of this is that Google has been developing and using containers to manage our own applications for over 12 years. So we've been using containers for a long time in technical terms. As technology just moves so fast. If you're familiar with containers, a lot of people started to become familiar with containers since 2014 when Docker came out. But an important thing to know is that containers existed well before Docker. In a few different forms, there were Solaris zones and FreeBSD jails, as well as the Linux Container Project, which was an open source project to create containers in the Linux operating system. And then Docker came along in 2014 and made containers really, really easy to use. So they kind of took off and everybody started using them. And we have a lot of stuff in Google that runs in containers. And a fun fact is that in Google Cloud Platform, even the virtual machines run in containers, which you usually hear about the other way around. You usually hear about containers running in virtual machines. But yeah, I actually went and checked with the engineering team when I first heard this to make sure that it was correct, and it is indeed. So that's pretty cool. There are some reasons that you would want to do that, but I'm not going to get deep into the world of containers today. We're going to move into Kubernetes. So we launch a lot of containers. We run containers at scale, I would say. So before I jump fully into Kubernetes, though, I want to mention the cloud native landscape. If this is your first time getting familiar with Kubernetes or hearing about the cloud native landscape, I just wanted to give you a bit of a sense of what you're jumping into. And there are a few things that I think you'll want to learn a little bit more about. So here it is. You understand everything about cloud native now, right? The cloud native landscape is the butt of many a joke. This is my favorite because this is my life. My life is trying to explain this giant map of cloud native open source projects. But don't worry, today we are only going to be in this little box, and really even more, we're just going to be this little box right here, which you can barely even see. It's great, right? So that is my life. But today we're just going to be talking about Kubernetes. But as you can see, as you start getting into cloud native, the vast majority of the projects on this landscape are kind of built on Kubernetes. They're meant to extend what Kubernetes can do, add additional functionality, it's all kind of coming from containers in Kubernetes, I would say. A couple that are containers themselves, in which case that is containers. But one thing I also like to mention here is that even if a technology is known as cloud native, that doesn't mean that it only works in the cloud. It just means that it's designed to work best in the cloud. So the vast majority of projects that you see on this landscape, not that you can see any of them, but the vast majority of them can actually be run in all sorts of environments, not just the cloud. It just might be a little bit strange since they're generally designed to work best in the cloud. So diving into Kubernetes, fun fact, Kubernetes is Greek for helmsman. It is also the root of the words governor and cybernetic. And it's for managing container clusters. It's for managing the underlying infrastructure that you are going to run containers on, kind of abstracts away the actual machines and virtual machines that you're going to be running your applications on. And I mentioned Google's experience with containers at the beginning because Kubernetes itself is inspired by Google's experiences and internal systems for running containers at scale. If you've ever heard of Google Borg or the Borg papers, you can Google that and find more information about it. But Google Borg is the internal project that Google came up with to run containers at scale some time ago. And at some point, a few Google engineers saw that and thought, I bet a lot of other people would love to run containers like this. And so they came up with a concept for Kubernetes and open sourced it. June 6th of 2014 was the first commit. So it just turned 7 years old, which is very exciting. Congratulations, Kubernetes, on its birthday. So it was just on Sunday. And Kubernetes supports multiple cloud and bare metal environments. Like I said, even if a technology is cloud native, doesn't mean that it just runs in the cloud. I actually have a friend who once ran a Kubernetes cluster on a bunch of Android watches. So very flexible technology here. And Kubernetes actually supports multiple container runtimes. If you've heard of containers before, you've likely heard of Docker. There are other container runtimes, and actually Docker itself is not a container runtime per se, at least from Kubernetes perspective. Docker uses the container runtime containerd to do what it does. And containerd is on the cloud native landscape that I showed you all earlier. And there's also other ones like Creo is a popular one that people look at for running containers in Kubernetes. So there are a variety of ways that you can run containers in Kubernetes. And it's all open source. It's written in Go. And the goal of Kubernetes really is to allow you to manage applications while abstracting the machines away so that you don't have to worry about those as much. So now we're going to dive into some basics about Kubernetes. And to do so, we're going to use a fun analogy and some illustrations because that's how I like to do it. So I have a talk where I explain containers as cookies. I use this analogy for a variety of reasons, but the main thing I'm trying to get at with this analogy is to explain the benefits of containers. So you'll see here a chocolate chip cookie. And one reason I like to use the chocolate chip cookie as an analogy for containers is your goal with a container is to run some application. That's like the chocolate chips in the cookie. It's the best part, and it's really the reason you're there, at least if you're a chocoholic like me. So really, containers are all about applications. But applications don't always just run very smoothly by themselves. They often need a lot of other things, a lot of other dependencies and binaries and libraries in order to run well, I guess you could say. So a container gives you a mechanism for taking all of those extra ingredients and baking them up all together with your application into a portable package like a cookie. So one thing that people really like about containers is that they can be run on a variety of different operating systems and different types of machines. And so there are a few other reasons that I talk about containers as cookies, but I won't go deep into those today. There's another comic that I have on my website where I talk about container, like the Linux kernel mechanisms that make containers possible. And I use a different analogy for that. And it's a better analogy for explaining exactly how containers work, if you're interested in that. But this one does a good job of explaining the benefits of containers. And we're going to need that to talk about container orchestrators, because I'm going to continue with this analogy. So if containers are like cookies and Kubernetes is a container orchestrator, which is all about running containers at scale, then in this analogy, the Kubernetes container orchestrator would be kind of like a cookie factory. not because it's where the cookies are made. Cookies could be made somewhere else, but this cookie factory manages wide-scale cookie distribution at scale. So we'll dive into this a little bit more. So I'm going to introduce a few different Kubernetes objects, which are key to understanding how Kubernetes does what it does. The first one I want to talk about is pods. And pods are really how Kubernetes thinks about containers. From Kubernetes' own perspective, it hardly even runs containers. It doesn't really think about them. It thinks about pods instead. So when you want to run a container in Kubernetes, you're going to end up packaging it in a pod one way or another. So here on the right, we have a pod spec. So this is a YAML file that tells Kubernetes, hey, this is what I want to run. And one of the great things about Kubernetes is your ability to declare what you want to have running. You can define it in a file and then say, hey, Kubernetes, go make it happen. So this is a big benefit of Kubernetes. So here we've got our pod spec, and that's kind of like a package of cookies in this analogy, because kind of abstracts away the cookie itself and also has the ability to run not just one containers, but multiple. However, by far the most common use case is to run just one container in a pod. So why would you ever run multiple containers in a pod? The most common use cases for that I see are things like proxies. A lot of service meshes will put in what we call a sidecar container, which is put right in there in the pod, right next to your container that's running the app that you actually care about. And these sidecar containers can do things like acting as a proxy if, I think I already said that, but as traffic comes into the pod that's intended for your application, the proxy can intercept that traffic and make sure that it's allowed to talk to the pod, for example. That's one thing that a lot of service meshes do. A lot of service meshes also add in some logging and monitoring capabilities into the sidecar. So they'll grab logs from your existing application and put those into some dashboard for you or something if you want. So this way, with the sidecar container, you can get extra observability, logging and monitoring, or do some proxying or things like that without having to add any extra code to the application that you actually care about. So two containers in a pod will share storage space, they share network space, and they generally want to be two things that are very tightly coupled. So something like a sidecar, something that doesn't really matter on its own or doesn't make any sense on its own, but makes sense with the other container. So the next thing I'm going to talk about is replication controllers. And this is a really key part of Kubernetes. Something that it does really well is provide you with tools to run your application in a highly available way. So in this analogy, this would be kind of like multiple packs of these cookies at the store. If you picked up any one of these packs, pick a pack of cookies. If you picked up any one of these packs of cookies at the store, you would expect it to be pretty much the same, right? So there's an element of quality control here. So at the bottom, we have a command saying kubectl scale -- replicas equals 3 -f, meaning we're giving Kubernetes a file and the file name, which is demoapp.yaml. And from the output of that, we can see that what we were scaling is a deployment. So in the last slide, I showed you all a pod YAML manifest for Kubernetes. And like I said, Kubernetes thinks about containers in terms of pods. But with all of these highly available capabilities that Kubernetes has, like creating replicas, it has another object called a deployment. There are actually a few different types of objects that you can use this way. But basically, a deployment kind of owns your pods for a specific application and can take care of them and do things like creating replicas of them, doing rolling upgrades. If you make a change to the, say, the container image or something, the deployment has some smarts built into it to be able to roll out that upgrade instead of just kind of killing all of your containers and then bringing them back up in some kind of disruptive manner. So deployments are really useful for any kind of application that you want to have consistently running. And it's generally best for stateless applications. So things that don't need to have state. If they disappear off the face of the earth and their storage goes with them, then that should be okay. So a deployment is a type of replication controller. There are others, for example, ones for stateful applications. And the purpose of replication controllers is kind of quality control. It's to help make your applications highly available with, I guess, kind of as little extra effort from you as possible. And the next thing I want to talk about is Kubernetes scheduling. So technically, all of these containers are still running on bare metal or virtual machines, some kind of infrastructure somewhere. So that's kind of like this container that I'm showing here. So Kubernetes has to decide where those pods are actually going to run, on what actual hardware they're going to run. And that's what we call Kubernetes scheduling. And there's a question here, so I'm going to pause and take it. Can you roll over only some containers in a pod? Say you have a stateful container and you want it to be up 100%, but an app, and you want it to be up 100%, but an app that you want to restart. So generally, like I said, by far the most common case with a pod is to have only one container in it. It's kind of a logical unit, the pod. I think any case where you're in a situation where you would want to restart one container in a pod, but not the other, they probably shouldn't be in the same pod. So yeah, that would be my advice there generally. Yeah, cool. I'm glad that made sense. Yeah, and stateful sets are what you would want to look at for stateful containers, which I haven't messed with as much as I would like to. I would like to play with those a little bit more and see how they compare to deployments, which I use far more frequently. Anyway, back to scheduling. So we're talking about putting those pods onto actual infrastructure, onto actual hardware. And I have here, again, another pod spec. And something I didn't mention before, if you look right under the pod, kind pod line in this pod spec, there's a metadata section with name Nginx, and that's the name of our pod. And then it's got some labels. And here we've got the labels env test. And you can put anything you want as labels on a Kubernetes object. You could put foo bar if you want to. But these labels they can be just for fun, but they can also be used for very useful things in Kubernetes, like the node selector section here in this pod. So in this node selector, we have disk type :SSD. And this is the same format as that label that I just mentioned, the env test one. And that's because it itself is a label. So while the infrastructure is real, of course, it's a bare metal server or a virtual machine or what have you, it's also abstracted in Kubernetes and represented as an object. So if you run kubectl get nodes, Kubernetes will output some information about all of the node objects that it knows about. And since those are objects in Kubernetes, you can also add labels to them, which can be really useful, such as this disk type SSD label, which again, it's a label. You can put anything you want. You could put foo : bar, but it's nice to have useful labels. So this is telling Kubernetes, hey, I want to spin up a pod that's running an Nginx container, as we can see from the manifest, and I want it to run on a machine that has an SSD. And when Kubernetes does its scheduling, it'll take that into account and try to make that happen. So this is just a really basic overview of a few components of Kubernetes. There are a lot more, of course, to dive into. There are other types of replication controllers, RCs, which you can, I guess you wouldn't really do that now. So there used to be something in Kubernetes, by the way, a Kubernetes object called the replication controller. And that has been kind of foregone for deployments and stateful sets, jobs, and cron jobs. So these other types of replication controllers within Kubernetes. So each one of those is a type of object that's meant for running containers in a highly available way. If you ever do any kind of Kubernetes basics tutorial, you will end up spinning up a service. when you create a container in Kubernetes, how are you going to access the application that's actually running in that container? Services are the answer to that question. So there are a few different types of services. I really want to add this in as slides, but I haven't figured out how to work it into the cookie analogy yet. If you have a thought, please let me know. But services have a few different types. Type cluster IP means that that application will only be accessible to other applications within the Kubernetes cluster. So that can be really useful. There's also node port, which is kind of weird in Kubernetes, really, but can be useful sometimes in a lot of different ways. So node port means I want this application to be available on a port on the actual node it's running on. Since Kubernetes is kind of abstracting away all of the machines underneath it, sometimes that can be a little strange because you have to figure out which actual node your actual pod is running on, and then you can access it through the port on that node. And then there's load balancer, which is an element of that cloud native thing I mentioned. Load balancers make so much sense in the cloud because generally, if you're using something like a managed Kubernetes service, which we're going to talk about next, and please let me know how I'm doing on time if I need anything. But anyway, if you're using something like a managed Kubernetes service like GKE, it will be pre-configured to understand that you're running in Google Cloud, and it can spin up a load balancer resource in Google Cloud for your application to use. And that makes it so that your application can be easily available, say, on the internet. So load balancers are such a lifesaver. They make things so easy in the cloud, but they can be a little complicated if you're running things on premises, because then you have to actually use a node port to connect your pod to an existing load balancer. It's a little complicated. Anyway, also we mentioned persistent storage for stateful applications. In Kubernetes, those are called persistent volumes and persistent volume claims. So definitely look that up if that's an element of interest to you. It's one of my favorite topics to look into, even though I haven't gotten to play much with it in recent times. But there's also namespaces. So namespaces and role-based access controls are really important to understand with Kubernetes. And what namespaces give you is you can, like a common use case for namespaces would be like a production namespace and a test namespace, or I'd say even more common is namespaces for different teams. And then you can use role-based access controls to control which users can deploy into which namespaces. So things like that. And you can kind of split up a cluster that way so that it can be used across multiple teams or use cases. So that's a little bit of introduction to Kubernetes itself. And now I'm going to talk about Kubernetes in the cloud with Google Kubernetes Engine and all of that. Maybe something concerning accessing cookies in a vending machine or a cookie jar, or a specialty store or something. I like this. I like the way you think. I'll be thinking on that. Kind of like the vending machine idea. I think there's something there. Anyway. So running Kubernetes from scratch, open source, is pretty difficult. This slide is a little bit of a reference to Kubernetes the Hard Way, which is a guide on GitHub if you haven't seen it before. It's by Kelsey Hightower, who also works at Google. And it walks you through spinning up a Kubernetes cluster from scratch. It's fantastic for understanding how Kubernetes actually works and getting a sense for all of the components that go into making a Kubernetes cluster, particularly all of the things that go into making the control plane of Kubernetes. But if you're trying to run Kubernetes for your business or trying to run it in production, that's a lot of things for you to have to think about. I once created a Kubernetes kind of the hard way guide for a specific environment for a past job, and it was 40 pages long. So this can be pretty tough. There's a lot of things you have to think about in the control plane. You have to worry about all of the worker nodes, provisioning and managing those, the security of those nodes, making sure that you keep them patched and upgraded, making sure you keep Kubernetes itself patched and upgraded, all of the monitoring and management of the cluster, and all sorts of things. So it can be done. There are certain businesses where it's really important for the business to do things this way and to run them themselves. But for probably the majority of businesses, that's more than they really need to worry about. And so cloud providers looked for a way to give Kubernetes to their customers in an easy way compared to Kubernetes the hard way. Get it? Make a lot of jokes about that. So the idea with any managed Kubernetes service you find in the cloud will be to basically start a cluster with one click. And you'll want to be able to view your clusters and workloads in some form of dashboard. I know that Google Cloud does a good job of having a lot of different types of dashboards available and kind of showing you what's happening in your Kubernetes clusters well with a dashboard. And in the case of Google Kubernetes Engine, you've got Google, who have been running containers for a very long time. And since Kubernetes has been around, Google's been running a lot of Kubernetes clusters. And so you have us taking care of the control plane of your cluster. For most managed Kubernetes services, the cloud provider then manages your control plane of Kubernetes and takes care of it and makes sure that it stays running. And that is the case with Google Kubernetes Engine. So I don't think I actually have a architecture diagram, unfortunately. But basically there's the control plane and Google manages that. But then the worker nodes that your containers will actually run on, all of your applications will actually run on, generally speaking, you pick those and you kind of take care of those a bit in managed Kubernetes services. And then there are other cloud services that you can also connect your Kubernetes cluster to. So it changes what you have to worry about. It reduces what you have to worry about a little bit, in theory. That being said, there are two modes of operations of Google Kubernetes Engine, which are standard mode, which is how GKE has been running for almost 6 years. I think it turns 6 in August. And Autopilot Mode, which is brand new. It just came out in March. So like I said, doing it yourself, there's a lot of stuff that you have to worry about when you're running an open source Kubernetes cluster. Managed Kubernetes, like GKE standard mode, there's quite a bit less, I guess you could say. Google's then taking care of the control plane. We're giving you a bunch of useful tools for understanding what's going on in your cluster with the dashboards and things. We take care of a lot of the challenges around upgrading the cluster. But there's still some things you have to worry about, like patching and upgrading and making sure that your compute nodes that you're going to be running your containers on are secure, and worker node provisioning and management. So in a GKE standard mode cluster, you still have to pick what machine types, virtual machine instance types in Google Cloud you're going to be running. Do you want X amount of CPU and Y amount of memory? Then you got to pick the right instance types for that. So you have to have a pretty good understanding of the types of applications you're going to be running in Kubernetes, and then get a sense of how many machines of which sizes you're going to need to be able to run those applications in the way that you think they're going to need to be run. So there's a lot of observability that needs to happen there, and understanding that needs to happen there. And so Autopilot Mode takes this managed Kubernetes concept a step further. And instead of having you take care of figuring out which nodes to provision, instead Google takes on that as well. So we're now managing your control plane. You wouldn't see that in your cloud console, and you wouldn't see your nodes in your cloud console either. We're going to pick those for you based on your pod definitions, like I showed you earlier, your workload definitions, and you can use things called resource requests and limits to make a request of this application is going to need X amount of CPU or memory or what have you, and CPU or memory. And then you can also place limits on your application so that they don't take up too much. So Autopilot looks at those types of things and tries to pick nodes for you. So the goal here is to provide a more hands-off experience, optimized for production like a Kubernetes expert. These are our goal here is to kind of make it a lot easier to get going with Kubernetes, since you won't have to worry about picking those virtual machines and taking care of them as much. It gives you a bit of a stronger security posture when you hit that button to create a cluster, because now Google is in charge of taking care of those nodes. We have a hardening guide in the Google Cloud documentation of recommendations for how you should secure a node. And now, since we're taking care of those nodes, we have to take on a lot of that responsibility for you. Google is your site reliability engineer. Site reliability engineering is a discipline that Google invented and likes to talk about and write books about. And the concept there, since Google is a website, taking care of the reliability of that website. So site reliability engineers are people who keep things going. So Google has a lot of experience running Kubernetes clusters and is taking care of your Kubernetes cluster in theory. Well, if you're using Autopilot Mode or managed Kubernetes service GKE. Improve resource efficiency. So like I said, if you are picking your own virtual machine types and sizes, then you have to have a pretty good understanding of what applications you're going to be running and how much traffic you think you're going to be getting for them and that kind of thing. But in the case of Autopilot, we are kind of judging what's happening for you and scaling based on what we see. So we take care of a little bit of that for you. I'm going to talk about autoscaling here in a second. And it's still Kubernetes. If you've ever used open source Kubernetes anywhere else, it's going to be the same commands and same objects and same resources. If you're familiar with using Google Kubernetes Engine in standard mode, there's a lot about GKE Autopilot that's the same, but it just takes that part of kind of running the nodes, managing the nodes off your hands a little bit. And an important thing that I want to mention here is that since, so in GKE standard mode, it's a pay per node model. If you pick a virtual machine type of, well, depending on which virtual machine types you choose, you will pay different amounts based on the machine types, which is all in the documentation. But in the case of Autopilot Mode, we're taking care of those machines for you and picking which ones you're using. So it doesn't make much sense for us to charge you on that. So instead, in Autopilot Mode, it's pay per pod or pay per resource, which I think I mentioned earlier. So now we have actually a pod level, service level agreement saying that we are guaranteeing 99.9% uptime of Autopilot pods that are deployed into multiple zones. So you still have to think about deploying your pods in a highly available fashion. But when you do, we have an SLA for the pods themselves, which I think is really cool. And I like to show off this slide as a way to compare Autopilot Mode to serverless. That's a common thing that I hear. And Autopilot Mode is a little bit different from serverless. One of the things on this slide, and this is a bunch of different use cases or workloads that you could run on GKE Autopilot Mode. And one of them is unprivileged per node workloads or daemon sets. That is a Kubernetes object type where you run a workload on every single node. So that doesn't make much sense with serverless, since you're basically pretending that the servers do not exist. In Kubernetes GKE Autopilot Mode, the nodes are still there. You're just not choosing them, and you aren't able to SSH into them or mess with them at all. But if you ran kubectl get nodes, you would still see the node objects in Kubernetes because they are still there. So it's more like nodeless Kubernetes, where you're just not worrying about the nodes, but it's still Kubernetes rather than the full serverless model, even though the payment model of paying for according to the resources that you're using sounds a bit similar. So now I'm going to go into autoscaling a little bit here, and let me know how I'm doing on time. But the top two here are autoscalers that are available in Kubernetes. So if you're running a Kubernetes cluster anywhere, you should have access to these. Ooh, 3 minutes. I'm going to be really quick then. So horizontal pod autoscaler is if you need, it'll watch what's going on with your pods and then create more pods or have less pods, depending on what's going on. Vertical pod autoscaler sets those requests and limits, like I talked about earlier. Cluster autoscaler is more or less nodes. Say that you run your horizontal pod autoscaler and it creates a whole bunch of pods and now all of your nodes are full. Cluster autoscaler can detect that and spin up more nodes for you. And that's a GKE specific thing, Google Cloud specific thing. And then node auto provisioning is selecting the sizes of those nodes for you. Like I said, that can be pretty challenging. And that's again a GKE cloud specific, Google Cloud specific thing. So autopilot mode is basically just running those bottom two things for you. Everything that's auto scaling your nodes we're just taking care of that for you. And so in autopilot mode, all you would think about would be the horizontal pod autoscaler and the vertical pod autoscaler. So that was really fast, but I hope that you learned some fun new things. And thank you so much for joining.
Yes, thank you, Kaslin. We really enjoyed that. Does anybody have any questions before we wrap up? And Kaslin, feel free to answer any questions. But again, thank you all for joining. Again, that was awesome. It seems like the audience enjoyed it. But Google will be here today for a couple more hours and tomorrow. So feel free to ask any questions or pop back into their booth tomorrow. Kaslin, are you going to stay around for a little bit after this talk?
Yeah, I can hang around for a bit.
Okay, so Kaslin will hang around. You don't have to stay too long because I know it's pretty late in some parts of the world. But again, thank you. We really appreciate you all for joining. And I hope you all are enjoying yourself and having a good time. After you leave this booth, there are still talks happening until 11 p.m. Eastern Standard Time. So feel free to check out other chats. I am going to disappear. Kaslin will hang out for a bit, but she won't be here forever. So you can always maybe get in touch with her outside of this conference. I'm not sure if she's going to share that information, but if she does, feel free to contact her in other ways. So thank you. Have a wonderful evening, and we are grateful that you're here.
Thanks.
Bye.
Bye. Yeah, so you can contact me anytime on Twitter at Kaslin Fields. I generally try to be pretty responsive there, though I have at least one message on there that I've been meaning to respond to for a while. And